Hello folks, I'm Caster. Welcome to our YouTube channel. As you read the title of this video, that JWT with local storage bad over cookies, and clicked to watch it, right? So yeah, when I am building web apps, there were always doubt in my mind. There are two ways of authentication. Some developers are using JWT tokens and store inside local storage. Then why cookie exists? Cookies are old way of authentication, but bigger platform always uses cookies like Google. Then why they don't get migrate from cookies? Which one is safer to use over each other? So in this entire video flow, we are going to understand things from scratch. So let's jump directly onto the presentation part. Okay, so I have just divided this entire video flow into the two parts where in first part we will see the high level understanding of authentication, after that client side rendering and server side rendering, how authentication basically work in client side rendering, what is XSS attack, what are the causes of XSS, that is cross site scripting, and we will simulate this attack in our laptop. In second part, we will see authentication works in SSR, that is Next.js, and what is the CSRF attack. We will simulate CSRF attack also. After that, we will deep dive into the cookies, how to avoid the CSRF, and at the last, we will see which one is the best approach for authentication and the comparison part. Now, let's see the high level of authentication works in the web apps. So, in this diagram, there are mainly two entities, one is user and one is browser. When user put their credentials into the browser's form, browsers will make request to the web server, that is login request. Browser validate that request and forward it to the auth service. Auth service will look up the database that user is exist or not. If users exist in the database, it generates the session token and store into the session store. After that, web server responds back with that token, and browser saves this token into their cookie store or into the local storage. When browsers want or user wants to make request which is protected request, then with that request, browser sends the required token or cookie to the web server. Web server again validates that token, and if the token is valid, then request or the response back with the protected things or the protected data. That's how the authentication works in the web apps. Now let's understand client-side rendering flow or CSR. I am going to walk you through exactly what happens when you visit a React application. So for that, I have created one React application. You can see on your screen. When we inspect this, going to the network tab, after we hit reload, you can see first blank HTML comes. So if you wonder why all website shows a blank screen for a few seconds before content appear, we are breaking down the complete flow from the moment you hit enter on a URL to when you finally see the full render page. So let's jump right to it. On your screen, you can see a sequence diagram that shows 6 key components: the user browser, a CDN, the React app bundle, your backend API, a database, and of course, the user at the end. Here's what actually happens. First, when you visit a website URL, your browser makes a request to a CDN. The CDN immediately returns a minimal HTML shell, and this is important. It's just a basis div with an ID of root. That is it. No content yet. Second, your browser then downloads the JavaScript bundle from the CDN. This bundle contains your entire application code. Third, once the bundle is downloaded, React initialized and renders a loading state, and here is the catch. Your initial HTML is empty and SEO unfriendly. Users see a blank screen during this JavaScript load time. Fourth, the React apps make API calls using Fetch to your backend, which queries the database and sends back JSON responses. Finally, React updates the DOM and renders the actual content. The fully rendered page is displayed, and this typically takes about 3 to 5 seconds. Alright, now that we have seen how client-side rendering works with that blank screen and loading delay, let's look at a much better approach, server-side rendering with Next.js. So here, I have Next.js application running. Now watch what happens when I right click and hit inspect element. If we open the network tab, if we hit reload, you can see the HTML file here. Look at this. Can you see the difference? The HTML is already fully populated with content. We have got actual text, data, and elements that here in the source code. This is not an empty div, this is a complete HTML page that was rendered on the server. And if I check the page source, look at the initial network response. Boom. The server sends a fully rendered HTML document. This means search engine can read it, social media crawlers can preview it, and mostly importantly, users sees content immediately. Now let me break down what's actually happening behind the scenes with this flow diagram. Here is the complete server-side rendering flow with Next.js. Step 1. When you visit a website URL, the request goes directly to the Next.js server, not a CDN serving static files. Step 2. The Next.js server immediately runs the server-side props function. This is a special Next.js function that executes on the server before rendering the page. Step 3. Inside get server-side props, we fetch data from our backend API, which queries the database and returns the result back to the Next.js server. Step 4. Now here is the magic. The Next.js server takes that data and renders your React component to HTML on the server itself. It generates a fully formed HTML document with all your content. Step 5. This fully rendered HTML is sent back to the user browser. And notice the key difference here, the browser displays content immediately in just 1 to 2 seconds. No blank screen, no loading spinner, just instant content. Step 6. After the HTML is displayed, Next.js performs something called hydration. It downloads the React JavaScript bundle and hydrates the page, basically attaching all your event listeners and making the page interactive. And at this point, the user sees content, can interact with it. The page is both fast and initial load and fully interactive. So if I refresh this page, watch how quickly the content appears, no blank screen, just instant SEO friendly, fully rendered HTML. This is why Next.js and server-side rendering have become so popular for production. You get the best of both worlds, fast, first content, full paint, SEO benefits, and still maintain all the interactivity of a React application. Now we will see JWT, that is JSON Web Tokens with local storage approach in client-side rendering with React. This is the JWT with local storage pattern that many React developers use. Here what happens when a user logs into a React application. First, the user opens your React app and enters their credentials, email and password in login form. Second, the React app sends a post request /API/login with those credentials to your backend API. Third, the backend receives the request and validates the credential against the database. Fourth, we hit a decision point. Is the credential valid? If no, the auth service return a 401 unauthorized error message and the user is denied access. But if yes, the credentials are valid, the auth service generates a JWT token using JWT.sign function with a payload and secret. This token contains encoded user information. Fifth, the backend returns this JWT token in the response. And here is the first major problem. The React app receives this token and immediately stores it in local storage using localstorage.setItem function. And this is where we have our critical security vulnerabilities. Local storage is accessible by any JavaScript running on your page. This makes the entire JWT plus local storage approach vulnerable to token theft and XSS attack, that is cross-site scripting attacks. Now let's say the user navigates to a protected route like slash dashboard route. Here what happens? First React reads the JWT token from local storage using the localstorage.get function. And look at this. Here another critical vulnerability. Any JavaScript code on your page, including malicious scripts, can access this token. This is this exact vulnerability we are about to demonstrate. Second, React makes an API request get slash API slash profile and adds an authorization header with the bearer token containing the JWT. Third, the backend validates the JWT token. If the token is not valid, it returns 401 unauthorized and redirect the user back to the login page. But if yes, the token is valid, the backend returns the user data, profile name, email. Finally, React surrenders the dashboard with the user data and the user can now see their protected content. Now here is the critical issue you need to understand. This yellow warning box summarizes everything. Local storage is accessible by any JavaScript including XSS attack. If an attacker injects malicious JavaScript into your application, maybe through a third-party CDN and an unvetted npm package, or any user input that isn't properly sanitized, that script can easily run the malicious code and boom, the attacker now has your user's JWT token stored in local storage. In the next slide, I am going to show you exactly how this attack works in real time. I have uploaded a malicious JavaScript to an AWS S3 bucket and serve it through CloudFront as a CDN. The attack script will be read all token from local storage, capture all cookies from the browser, exfiltrate this data to the attacker's domain in seconds. Innocent third-party script loaded via CDN can completely compromise your user's authentication. This is not theoretical attack. This is in real, this is in common, and this is why local storage for tokens is a critical vulnerability. Never ever store JWT token in local storage for production application. It's convenient during development, it's simple to implement, but it's a catastrophic security risk. This is JWT local storage approach in CSR leaves your users vulnerable to access attack via malicious script, token theft from CDN vulnerabilities, session hijacking if the token is exposed, account takeover without the user knowing. In the next part of video, I will show you the attack in action and then we will explore how Next.js with HTTP only cookies and server side authentication solves this problem completely. Alright, so JWT tokens in local storage are incredibly vulnerable. Let's understand how an XSS attack actually works and why it's so dangerous. XSS stands for cross site scripting. It's when an attacker injects malicious JavaScript into your website. Here, what makes things devastating. The attacker script can steal JWT tokens directly from local storage and send them to their own server. And because local storage is accessible to any JavaScript running on your page, there is absolutely no protection. In our demonstration, we are using a malicious script loaded from a third-party CDN, specifically AWS S3 with CloudFront. This mimics real-world attack scenarios where compromised npm packages or malicious CDN script get loaded into production apps. The scary part, the attacks happen silently in the background. The user never knows their token has been stolen until it's too late. And once the attacker has your JWT token, they can impersonate you completely. Access your data, make purchases, delete your account, everything. Now, we are going to see this attack in action. First, I will show you the high level architecture, then we will perform it live on a React application that we created earlier. So before we dive into the live demo, let me show you the three key components of this attack. First, we have AWS S3 CloudFront CDN. I have already uploaded a malicious JavaScript file called XSS exfiltrate attack.js to an S3 bucket. CloudFront is serving it globally, making it look like legitimate CDN resource. This is how attackers distribute their malicious code through trusted infrastructure. Second, we have the victim browser with local storage. You can see here we have JWT token, user data, session information, all stored in local storage. Notice how everything is accessible. There is a token key with a long JWT string, user ID, session data, all of it exposed to JavaScript. Third, we have the malicious script itself. This is the actual code that we will execute in the victim's browser. Let me walk you through what this code does. It immediately collects all local storage items, every single key value pair. It grabs all cookies using document.cookie which are not HTTP only. It captures the current URL, the user agent, and timestamp everything. Then it sends all of the stolen data to the attacker server using a post request to localhost 4000/steal route. In a real attack, this would be the attacker's remote server. And notice the clever part. It uses mode which is no CORS. To bypass CORS restrictions, even if the request is blocked, it has a fallback using an image beacon trick that always works. This is production grade malicious code. It's robust, it has fallbacks, and is designed to steal data no matter what protection you are think you have in place. Okay, so now let's see the complete attack flow from start to finish. Here what happens. Step 1. The injection method, we inject a script tag into the React Vite apps index.html file. When the user browse loads pages, the request this malicious script from AWS S3 and CloudFront. The CDN returns the JavaScript file and it executes immediately in the user's browser. The script reads all tokens from local storage, captures cookies, and collects browser data. It sends everything via post request to the attacker server at local storage at localhost 4000 port. The attacker's Express server, built with Bun, logs all the stolen data, JWT tokens, cookies, user information, session data, everything. Point to vulnerability, and that's it. The vulnerability is clear. Local storage is accessible by any JavaScript with no protection against XSS. Tokens are stolen in milliseconds. Alright, now let's actually perform this attack live. So first, I need to create attacker server. Let me open VS Code. I am creating an Express server using Bun. This will be our attack server running on port 4000. Perfect. The attacker server is now running on port 4000 and ready to receive stolen data. Now let me open the React Vite application we created earlier for the CSR client-side rendering demo. I am going to inject the malicious script into the index.html file. This simulates what happens when a compromised dependency or malicious hidden script gets into your application. There it is. One innocent looking script tag pointing to our malicious JavaScript file on CloudFront. This is all an attacker needs. Now let me open the React application in the browser. I will make sure I am logged in so we have JW tokens in local storage. The app is running normally. The user has no idea anything is wrong. They see this dashboard, their data, everything looks fine. Let me show you local storage. See these JWT tokens, user sessions data. This is what we are protecting. Now watch what happens when I refresh the page with that malicious script injected. Look at this. Do you see that post request to localhost 4000 still? That our malicious script in action. It just sent all the local storage data to the attacker server. Here is the request payload. You can see all the local storage items, cookies, URLs, user agent, everything has been exfiltrate. And now the moment of truth. Let's look at the attacker server's logs. There it is. The attackers know everything. The JWT token, the session ID, user information, complete access to these user accounts. And this happened in milliseconds. The user didn't see any warning. No pop-up, no suspicious behavior. The page loaded normally. And their session was completely compromised. This is exactly why storing JWT tokens in local storage is a critical security vulnerability. If you're using React application and storing authentication token in local storage, you need to change your approach immediately. Your users are vulnerable to account takeover, data theft, and session hijacking. So, what's the solution? Server side rendering with HTTP only cookies. In the next part of this video, we will show you how Next.js handle authentication securely using HTTP only cookies that JavaScript cannot access. We will demonstrate how SSR protects against these exact XSS attacks and why it's the recommended approach for production applications. Alright guys, that was insane, right? We just demonstrate a real XSS attack from scratch. Malicious scripts, stolen tokens, compromised accounts, the whole 9 yards. But here is the thing, we are not done yet. I will see you into the next video. Stay secure, keep coding, and remember, never store sensitive token into the local storage. Peace out.